Hello everyone. Okay, so let's solve this problem using trigonometric substitution. First of all, what is the substitute? So if you look at the square root part, so it contains plus x square plus 25. So substitute should have something to do with tangent, right? Okay, so what is a? So here a square is 25, so a should be 5. So this is the correct substitute. Now let's differentiate dx over dt because substitution involves two substitutions, right? You have to replace x and also dx. So where did this t came from? Well, dx over d theta. I'm sorry about that. Okay, so derivative of tangent. What is the derivative of tangent? Secant square. So if you don't know that, you have to write it down. Okay, remember that. You need that a lot. So derivative of tangent is secant square. So dx is going to be 5 secant square theta d theta. Perfect. Let's do the substitution now. So 1 over x square is 5 tangent theta square, and here x square is 5 tangent theta square plus 25, and dx is 5 secant square theta d theta. Okay, do not forget any terms. Okay, all right, now if you look at the integral, we no longer have x anymore, so we are good. We have done the substitution correctly. So let's proceed. First of all, let's simplify the square root. So let's keep writing these terms, because if you forget them, if you drop them, you're in a big trouble. So here 25 tangent square theta, here this will be 25 tangent square theta plus 25. Now we can factor 25 inside the tangent. Okay, so here 25 tangent square theta, so here 25 tangent square theta plus 1 if you factor 25, right? Okay, so now what is tangent square theta plus 1? By the Pythagorean identity, tangent square theta plus 1 is equal to secant square theta. So let's replace that. 5 secant square theta d theta over 25 tangent square theta. This will be 25 secant square theta. Let's take the square root now, because you don't have any addition subtraction inside the square root. So 25 tangent square theta, square root of that is 5 secant theta. Okay, right, now let's simplify this as much as possible. 5 cancel out, 1 secant theta cancel out, so what we are left with is secant theta over 25 tangent square theta. Now how are we going to integrate this? Well, we are not comfortable with having secant and tangent in the denominator and numerator. Seems to be like too complicated. Let's convert them into sine and cosine. So secant theta is 1 over cosine theta over 25 tangent square theta is sine square theta over cosine square theta. Alright, so division here means it's reciprocal multiplication, so we can write this as 1 over cosine theta. Let's take this 25 outside the integral, and reciprocal of this is cosine square theta over sine square theta d theta. We can cancel out a cosine theta, okay, but 1 cosine theta is left, sine square theta here. Alright, what are we going to do now here? We still have trigonometric functions in denominator and numerator. Well, how can we integrate them? Can we use trigonometric integration, any trigonometric identities that we learned in the last video series? Unfortunately, we can't, right? Because here we have a fraction. We didn't deal with fractions in trigonometric integration problem. Let me show you how to do this. This is a complicated example. Here we have to use integration by substitution. Yes, what is our substitution is going to be? Well, here you don't see an inside function right away, but let me choose w to be sine theta. Okay, because sine square theta, it's not an inside function, but inside the fraction you have sine square theta. So let me choose w to be sine theta. I will exactly show you why. So if you do the substitution, you have to take dw over d theta. So derivative of sine theta is cosine theta. So what is d theta? Because we want to replace d theta by dw. So d theta is dw over cosine theta. So do that step carefully. Alright. Okay, so let's substitute back. 1 over 25 cosine theta, here w square, right? Sine theta is w, d theta is dw over cosine theta. See why I use sine theta as a substitute? Then I can get rid of cosine theta just like that. Okay, all right, I could have choose w as cosine theta, but it will not help me here because I have sine square theta. It will help you to cancel out one sine theta, but one sine theta will be left. So the ideal substitute here is sine theta. Okay, try to choose substitute as cosine theta and see what happens. Okay, just see it by yourself. Alright, here it's 1 over 25, 1 over w square, it's w to the negative 2, right? 1 over w square, I write w square in the numerator, so it's w to the negative 2. Let's integrate 1 over 25. If you integrate w to the negative 2, it's w to the negative 2 plus 1 over negative 2 plus 1 plus c. Perfect. So this is 1 over 25. This is w to the negative 1 over negative 1 plus c. So it's actually negative 1 over 25w. Let's take w to the negative 1 to the denominator. This is the solution. So what is w? W is sine theta, right? Is that sine theta? Just yes, sine theta. Okay, so this is the answer. But we are not done yet. We change from w to theta. Now we have to write it in terms of x again, right? So to do that, we use the substitute. So x is equal to 5 tangent theta was the substitute in the beginning of the problem. So tangent theta is x over 5. Let's draw a triangle. Here let's mark theta. So tangent theta is opposite over adjacent side. So opposite side length is x. Adjacent side length is 5. So by the Pythagorean theorem, so let's call this c. So x square plus 5 square is equal to c square. So c is going to be square root of this, right? So the missing side is actually square root of x square plus 25. 5 square is 25. So we have sine theta here, 1 over 25. Sine theta is opposite over hypotenuse. So this is x over square root of x square plus 25 plus c. So division here is reciprocal multiplication. So 1 over 25. X will be on the bottom because of the reciprocal. So square root term will be on the top. Plus c. So this is what you get after integrating the problem. Okay. Alright. So this is a big problem, a long one. It involves several tricky steps. Okay. Alright, try to do the problem again by yourself. Now you have the video. Try to convince yourself how to solve the problem. Okay. I'll see you in future videos. Thank you very much.